for things that people wanted to talk about. And we had two things. Matt was going to talk about Knative integration, which is obviously a pretty hot topic at the moment. So Matt's going to talk about some of the work they've been doing to make OpenWhisk actions run on Knative and sort of the challenges and successes they've kind of had with Pretty. And then I think it's Erez is going to talk about the new load balancing tool. So proposed on the main list, new load balancing tool. Yes.
No, it's a benchmark tool. Sorry.
Sorry.
It's a benchmark tool. Yep.
Okay. My bad. So benchmarking tools. We're going to talk about a new benchmarking tool. We can learn about that. And then if we have time, I'll probably ask both the speakers to kind of keep to sort of 15 minutes-ish. I wanted to kind of highlight 3 interesting PRs that have come up that I think people should be aware of, just to kind of, for not everyone who follows the project as closely as some of the core people, then just to highlight a couple of things that are coming up that I thought were interesting and should be aware of. And then we can kind of close out an AOB, so if anyone wants to talk about anything else before the top of the hour. So let's start with some intros. If there's some new people on the call, I say, my name is James Thomas. I'm a developer advocate at IBM and the lead service advocate for IBM Cloud, which covers OpenWhisk. And I contribute to the project as well. There's definitely some names I don't recognize, right? But if you are you new? Are there new people who want to just very briefly say hello, what you've been up to, what you're interested in OpenWhisk, before we get on with AOB, with the next agenda item? People can speak up. Don't be afraid. Everyone's friendly.
I'm Erez. I think I've been to the previous session, presented some stuff, but just in case, I'm with IBM Research, working on OpenWhisk and serverless in general, and also looking into Knative.
Cool, thank you. Anyone else like to do a very quick intro before we jump in?
Yeah, hello everyone. This is Rahul from Adobe, and I'm a software product quality specialist there. I've joined previously as well. I proposed for OpenWhisk Karate, and I'm still working on that. And currently, I'm working on some deployment strategy. So I've created a quick wiki. If I get a chance, I'll talk about it after the call, or else I'll start a mail thread, and then we can go about it. Yeah.
All right, that's great. Thank you. Anyone else? I know in the chat, Lavanya says she's also from Adobe, or they're also from Adobe, but they can't speak at the moment. So hello, Lavanya. Anyone else?
Hi all, this is Manoj Mishra from Adobe. I'm working as a software quality engineer on the OpenWhisk and Blade Runner over there. Yeah, that's all.
Cool, welcome. That's great. That's nice to see some new faces. So why don't we go into the agenda now? And let's start maybe. Matt, why don't you start? And you've got probably 15 minutes and talk about some of the work you've been doing with Knative, which I know lots of people are very interested in.
Well, to be fair, I mean, this is Pretty show as much as my show.
Okay.
So it's fun, and so I'm gonna share my screen a little bit to set the stage, if I can. It's a little hard. I was note taking at the same time I'm trying to share here. So let me move my screens around here. There we go. All right, so hopefully you're seeing part of a slide deck.
Yeah, I can see it.
So, Pretty and I we're kind of new to the Knative space. We started looking around, kicking the tires a little bit in earnest in January, and then we got some more free time freed up, and we've had free time off and on for the past month or so, and we set about trying to see about what we could do to make our OpenWhisk runtimes be able to build with Knative and run in Knative as well, using Knative. And the concept was to try and create a build where we could set some flags and have some conditional code that would behave the way the runtime is expected to behave with the contract you have in Kubernetes / Knative versus the contract we have in OpenWhisk, which is where we have distinct endpoints in init and run, whereas in Kubernetes you're just being hit on the root of the domain name and expected to do everything on that root endpoint. So to that end, and it's been a struggle. I mean, Pretty can attest to this as well. Is that we thought we had some things going entering January, and then new versions of stuff came out, and every time a version of one part of the stack changes, we encounter weirdness or problems, and we've set about to do something that we found we've had little help with, for at least from our colleagues who have experience with Knative and Kube, which is we wanted to do this all in Docker desktop. So so what we've done is I'll show that we've been working in a private repo and under the auspices of OpenWhisk Knative build. We're trying to develop some really good docs and things about how to get set up to write some of the fundamental things. And some of it's redundant to what you'll find in Knative, but we've added a lot of like tips and tricks and things Pretty and I found along the way, as well as made it very specific to Docker desktop and giving you like sed commands and lots of hand holding along the way, because that's what we didn't get Pretty and I encountering Knative documentation. And maybe we'll submit some PRs back to Knative, but we're not there yet. And then what we did is said, and one of the motivating factors, which I say, I've released, I'm going to show all the slides, but what was called our attention in January, which caught a lot of people's attention inside IBM, was the fact that there's a company called Trigger Mesh who had a blog, and you can go look them up. And I'll share this presentation after all this is done someplace and post it to the dev list. But they announced that, hey, we took some Lambda functions and we built them using our own runtimes, and we can run them on Knative and run them on Lambda. And so it was suggested, this is kind of the path we wanted to follow with the OpenWhisk runtimes. Why can't we build for OpenWhisk and run them OpenWhisk and build them for Knative Kube and run them there? So what we encounter is some general philosophical differences. I'll leave this to your reading, but in general, I just wanted to say that the Knative space, and I encountered this talking to people in IBM. So people have been assigned to work in Knative come from the Kubernetes container space. So they think like container people. They think like DevOps people. They don't think like serverless people. They don't think about functions. They don't think about in-developer tooling. So, and that's what you'll encounter when you hit with Knative. If you're a serverless developer, you're expected to be well versed in Kubernetes and containers, and think in terms of single entry points, that you're just another container in the system. Once you're built, you're not special. You're not serverless. You're just another container. And then parameters in their stack are always environment variables. So we have to consider that in terms of how we initialize and how we run our code. That everything they expect to be baked into the container process environment variables at the very least at the end. So it's kind of a new mental paradigm for us, and we have to be very considerate of that in terms of if we go for stem cells and things in reuse. That we probably need to expose things in environment variables that are not comfortable, and we have to be security conscious. But going on, I just want to show kind of some things about our goals. But in essence, you heard the summary of it, and basically what we have is we took the Node.js 10 runtime because by far it's the most popular runtime in the IBM platform. On any given day, we can probably easily say, Carlos can probably attest to this, that it's in the probably the mid-high 90s of all the thousands of containers we have running. That most of them are Node.js, and it's no surprise because most of the guidance we give, for IBM and otherwise are Node.js samples and blogs and things, and so we decided, and of course Trigger Mesh showed a Lambda example, although they have Python and others. So we decided to start with Node.js since it was popular, and to see what we could change. And the goal was to do microsurgery. to see what minimal set of code we could change in a runtime that would enable us to run in both environments. And fundamentally, it involves just basically having some type of flag. And currently, we do a one-stage thing where we basically have conditional logic where we have a flag environment variable that tells us when the container modules initialize that to initialize running a init in the OpenWhisk manner, which is the default, or if you have a knative flag to not register in place of basically do a combined function that does init and then run, and basically sets all the appropriate states and doesn't throw an error and things after init. And so we can be hit on a single endpoint. And that's fundamentally it. And the goal that we're working towards now, pretty nigh, and have been, is to do what we call a two-stage build, where we want to have two build phases. The first build, we build a stem cell, and we basically only build in the code for Knative, or only build in the code for OpenWhisk. And so we minimize the code we actually build in the container, so both logics not active or present or runnable. And also do some really cool things. We talked about building init and retail versions. In fact, we've already proven that out. I can hopefully show that as an example if Pretty can't. I haven't checked with Pretty this morning because I know she was having a problem with her environment yesterday last we spoke, so hopefully she got that figured out. If not, I can run a brief demo. But we can, if you want to do profiling or logging, we can build custom images with a simple parameter on the build process to generate a container that emits different profile data or different debug information. It's pretty cool. So this is basically, if you're not familiar with Knative, and here's kind of the process. And this is my my view of it, which is basically you have a build that basically works against a build template. So you have a build template, which Priya and I created the build template for OpenWhisk runtimes. And we have a set of steps that are taken through to build our runtimes. And effectively, the build basically says, use this build template, and it points to the source saying what source you want to build. In this case, we're going to build from our Knative build repository. Hopefully in the future, if we progress and can submit a PR, this would point to our OpenWhisk runtime repo. We'll say, start with this OpenWhisk runtime repo, and take this through the build process to customize the container for Knative, or the target environment. And then basically, we studied a lot what Trigger Mesh did because it was interesting, and because they actually use the default builder that's used in some of the Hello World samples for Knative, which is the Kaneko builder, and they use it in a unique way, which was interesting. They actually use the binary, and they alter the Docker file to force it to do interesting things. So we followed that approach. So we didn't have to write code that checked out from Docker, checked in the image to Docker, do a lot of things. A lot of things are built into this container for us and can just reuse and invoke it. But what we did do is we can just say start with our image and apply the specific build steps that we want. And at the end of it all, then we have a final container in Docker Hub that we can run in a pod and through Knative, and it creates a plurality of containers running in a pod that have everything baked in. If you're familiar with what goes on Knative, everything's viewed as a final container. So in their view, you bake in the code. So if you look at Trigger Mesh, if you have Hello World, you get a pod of Hello Worlds. So, I mean, there's a lot of discussion that has to be had in the Knative world. Maybe it's going on right now. We've not had time to invest to see what's going on there. But, effectively, you get very little reusability. Basically, every time you create a slight variant of a container, you're expected to create a new image and deploy a whole pod of them. So, I'm looking forward to having the discussion to see where the state of things are in terms of reuse and having stem cells. But you lack a controller. You lack that thing to do injection and stuff like that. So you do get warm containers, but we've seen some weird things as well. I mean, even this morning I was looking at and just chatting minutes before the meeting started, pretty that if one pod gets acquiesced and gets terminated, you hit the endpoint, it tries to wake up the pod, but it's terminated, so it tries to create a new pod, and you get into a weird state where Istio gets confused, it seems. So you have to wait till the system acquiesces after perhaps a long period of time. In fact, most of the times I just force pods to just be destroyed to restart my testing. So the state of Istio and state of Knative is less than ideal for for cold starts, to say the least. Especially after they get automatically acquiesced or put back into a rested state. Just take you through some details and tell me if I'm taking too much time, James. But
you got about 10 minutes, Matt.
Okay, so basically, again, I'll post these slides, but I highlighted and color coded what parts are unique and what to look for. So again, we basically have the build template, which basically is installed into the system, which we invoke on our build, saying this is how we want to build OpenWhisk Node.js stem cell runtimes. Start with the stem cell, basically, this image. And the stuff in brown are basically what Kaneko uses. Basically says when we finish all the build steps, where do we check in the file at? Where do we check this thing, this thing, what registry? So we say Docker Hub and we say give it information. Here's the things that we add in terms of we have a debug flag and we can build and debug profile information, and we say do we want a Knative or OpenWhisk target runtime, and that gets built into the container. And then we basically, since if you're a Knative, basically we don't have an init, so we have to at the build time we have to build in everything we send with the init data. Basically build that into the process environment variables. So that's what we do. So you'll see here eventually, the code and things that are this is specification. Over here, you'll see that we actually in the build step we reuse Kaneko and we basically do what Programmesh does is we break into the shell. We create a shell and we basically alter the Docker file to inject that init data into the final image, and then we basically tell Kaneko where to place the image in Docker and where to build the final Docker file from. So the build looks like this. So if you want to build your function into this container, then what you do is you fill in, you can give it a name of your action, you can give it the things, and you give it your hello world function, hello name and place and things, and then you can basically serve it. You can say, you can basically, once it's in your Docker Hub, your image is built with your function in it, your code in it. You can say, run this thing, and here's my environment variables for name and place for your hello world, and that's about it. So Pretty, do you want to demo this?
I still don't have stable state. It's failing on me.
Okay. So I will be a poor substitute, but let me try. I tried this twice 15 minutes before the meeting started, so we'll see what happens. So I wouldn't be confused. I created a little script, which you'll see me reference. So as you can see now, we can see what these are all the pods that are running in the default namespace. And what you see here are the builder pods. So basically you saw the two things. I tried this twice, I built twice. And after they're built, they go to completed, but for some reason you have to manually remove them if you want to. So I'm going to basically, my image is already built. So I'm going to basically start at the final step, which is to deploy the service. Let me bring up my browser too and show you. I can show you the. I'm just doing the basic hello world. So we have a set of tests that Pretty has a pull request. She's enabling more test web actions right now, and things like that. JavaScript tests. We try to give you helpful. We're trying to create a whole battery of tests. We want to get equivalency to what we can do on our current runtimes as much as possible without a controller. But we have instructions about how to hit the endpoint, what control commands to use, and things like that. You can see those things. But what I'm going to do is apply the service channel, copy. So basically, Node.js world is created. We can actually go back and check the pods. Let me make this bigger so it doesn't scroll. So you can see that basically by default it starts 3 containers, and so it's initializing. You have to wait until now all 3 of the containers are running in that pod, and then if I can basically hit this with the init thing, and basically I have a set of init data already prepared in a text file, and that's checked into our repo as well. All the tests have the init run data checked in if you want to run them independently as well. So you can see I hit the curl. I hit, right now I built for OpenWhisk. I didn't build for Knative. So I hit the init endpoint. I got OK true. It's initialized, and then I can hit the run endpoint, and it says payload hello world. And if I built the one with hello world with parameters, I could pass the parameters in as I showed on the slides. So this is kind of what we're playing with. Again, we have a series of issues to get web actions, raw HTTP actions working, and get more and more use cases working. And once we have a set working, we want to take a step back and submit a PR where we say, here's what we believe the minimally invasive change to the core runtime would be. And also we'd like to play around with the Go proxy, because I talked to Michelle a couple weeks ago, and he indicated that even Node.js and the runtimes that don't use the action loop stuff could use it. So and we want to do things like right now we have a hard-coded logic saying if Knative not. What we'd like to do is I'd like to change it so it's a two-stage build, like I said. So we actually use like the HTTP in Node.js Express. We have a middleware. We have a middleware filter on the way in and the way out. I'd like to add. We do have to run certain things. We have to fix up stuff on the way in on the request, and we have to fix stuff out on the response. So I'd like to use that middleware filter as the next step. So we have a number of things we want to clean up and optimize before we submit a PR. But we hope to submit a PR in about a week or so, and that's kind of where we're at. Again, we want to get before we submit a PR. We want to make sure we can do some other things with the Go action proxy as well. Any questions?
This is really good. Thank you. There was a question in the chat from Roderick, which said, instead of modifying the runtime to bypass init, did you consider leaving the runtime alone and modifying the invoke protocol so that for some annotated actions, it skips calling init?
Open to suggestions. I mean, that's effectively what. Well, yeah, we could annotate actions, but it seems odd that you would force the developer to annotate a payload of some kind. The payload to them should just be the basic parameters in their function and things. So I'm open to suggestions, but love to have a discussion once we submit the PR. Absolutely, but we're just trying to, like I say, we're trying to fulfill the contract as we see it in Knative functions and in Kubernetes in general, which is single root endpoint. You hit it with curl and the function's baked in. That we're just trying to fulfill that same expectation for the Knative Kube community. If we do other things, I think it'll be odd to OpenWhisk community, and it'll be odd to the Knative community. So that's my visceral reaction to that.
Okay, that sounds good. Are those slides available externally?
Yeah, I'm going to, like I said, I need to trim out what I didn't show, because a lot of it's not finished for the two-stage build, and I'll just trim it down to what I showed today, and I'll post it on the dev list.
I think people are very interested in that. Okay, that's great. Thank you, Matt. And yeah, any further stuff we can take up on the main list or Slack. Yes, that's very good. Okay, so next, we're going to have some stuff about the benchmarking tool or load testing. Now I've forgotten already. How bad is that? But we're going to have some tests about a new performance tool from Erez.
Yeah, it's a performance test tool.
Performance testing tool. So yeah, go for it. Probably about 15 minutes if that's okay.
Yeah, maybe it will take even less than that. Okay, that's so fine. I'll start by sharing my screen. Okay, let's go with the presentation. So, hi everyone. What I'd like to present is a tool that I developed for some performance tests. As you know, we have some existing performance test tools in OpenWhisk, the work-based and the Gatling-based. Now, I'm working on an EU project that aims to integrate OpenWhisk as a foundation for latency-sensitive computation, event-driven. So we needed to benchmark both actions and rule performance. And turns out none of the existing tooling was suitable, so we developed one, and that's the overhead tool. So as I said, it has a few new capabilities. One of them is the ability, as I said, to benchmark rules and asynchronous operations, in addition to the usual synchronous invocations that all the other tools do. And the second interesting property of it is that it gives you some significant, I would say, latency profiling without any instrumentation. And the reason it's capable of doing that is because it cross-references information from the activation records in addition to timestamps collected at the client. So in case anybody jumps up and starts shouting clock skew, so yes, there might be some clock skew. I assume it is limited by the usual protocols such as NTP that limited to a few milliseconds range. In addition, the tool adds tunables. Additional tunables. One of them is ratio, which I'm going to explain shortly, and the other is parameter size, which obviously affects the computation when you try to mobilize a lot of data for rules or for action. So what is ratio? Ratio is something different for rules and for actions. For rules, ratio is the number of rules that are linked to the same trigger. So that what happens is that this having more rules increases somewhat the latency of reaching the action to be invoked by the trigger if the actions before that, the rules before that, are invoked asynchronously, but still there is some preparation time, and that causes the latency increase. For actions, ratio implies the bursty behavior in the sense that each client, instead of sending one action at a given frequency, doing one action invocation at a given frequency, it does a burst. And since we have concurrent clients, these bursts can join together up to a significantly large burst that can stress OpenWhisk and increase the latency that is measured. The last new property of the tool is so-called master apart mode, which is the idea there is to compare latency in OpenWhisk when OpenWhisk is under stress. So how do you put OpenWhisk under stress? This tool, as I already mentioned, generates several concurrent clients. So the first client is the master, the other are the worker clients. So the worker clients all perform some kind of uniform activity that puts OpenWhisk at a certain stress level, based on the configuration, and then the master does the latency measurement under this stress. So other than that, some general information. The tool is written in Node.js using the OpenWhisk client library, the cluster library, which allows it to fork several concurrent clients and several other dependencies. The output, after you put in all the settings, you just get one big CSV record in std_out that contains all the throughput and latency measurements in addition to all the independent variables, that is all the input, and some silenceable logging in the standard error, including the CSV header. So basically the expected usage would be to later import the CSV header into a spreadsheet and then catenate all the CSV records, whether automatically or manually. Okay. So how does the tool work? Generally, the master starts by forking additional worker clients, the master client. Then each client performs a specified activity once per some interval. That would be delta milliseconds. After warm-up iterations, the client signals the master and then continue invoking. Now, what is the activity? Either fire one trigger to which all the rules are associated, or invoke a burst of actions, either synchronously or asynchronously. Then after all the clients have signaled warm up to the master, then including the master to itself, then the master knows that everybody's that we passed some ramp up stage, and it marks the measurement start. When the master declares the measurement end based on time period or count, then it tells the workers to stop the invocations and send back the statistics. Each client, whether master or worker, builds the statistics. That's called post-processing, using both the local timestamps and the activation records. And then these stats are all sent to the master, which generates the output record. So a few details on. By the way, I sent the repository, the public repository GitHub. I'll just show it at the end of the presentation again, and there all this data already is in much more detail. So what latency is measured? So each client before an invocation takes a timestamp. That's BI. That's before invocation. If the invocation is blocking, is synchronous, then the client takes a timestamp also after the invocation. So that's the AI after invocation. Additionally, for every action that is invoked during the invocation, we have the action start, action end timestamps retrieved from the action activation. Then if we're using rule invocation, then you can see at the bottom chart, you can see there is the trigger start, and then after that there is the action start and the action end. Trigger start is taken from the activation record of the trigger. Action start, action end, as I already said. Other than that, the test action itself reports how long it took to compute as one of the return values, and based on that, we compute the periods that are marked in purple. Okay, so OEA, that's the overhead of entering the action. That's the time from BI, from before the action until the action starts. And then there is the AD, the action duration, from the action start to action end. There is D, that's the net action execution time inside the container that's being reported by the action. The total overhead until the action execution is OER. And in case of blocking actions, you get the full round trip and the overhead of the round trip, excluding the net action execution time. For rules, the same OEA, AD, OER, except we have also TA, that's the time from the trigger till the action starts, which involves, of course, also processing and generating the invocation of the previous actions in the previous rules associated with the same trigger. So that's for latent. That's what the tool, the purple values. That's what the tool records for latency. And for each period recorded, you get the average, standard deviation, minimum, and maximum. What do we have for throughput? So for throughput, it's a complex scenario, so we break it down into the elements and count each one separately. So each client, when it does an invocation, we call that an invocation attempt. Whether that's a trigger, whether that's a trigger fire that causes several rules to be invoked, or a burst of actions, and then there are several attempts of actions. Now, each attempt yields one or more requests, of course. Okay, if you invoke one action, then that's one request. If you fire a trigger with multiple rules associated, then you have multiple requests. Each request yields an activation or not. You could have an activation error. In case you don't have an activation ID generated, then that's an error, but we also count that. We count errors separately. And the last, successful invocation attempts are counted as full invocations. So we count one full invocation per rule and one full invocation per action, depending on the activity that is being measured in the particular test. Now, the attempts is essentially, if we think about all this behavior in kind of queuing theory terms, so attempts is actually the arrival rate. Okay, that's the rate at which requests arrive. And the invocation throughput is essentially the service rate, assuming all errors that occur are only due to overload. So based on this, we take all these counters. You have the absolute value of the counter, of course, and we can have the throughput by dividing the counter by the measurement period. And also we compute the throughput of the workers and the throughput of the master separately. That's for the master apart mode, to make sure that the master was operating at a low enough frequency so that it doesn't significantly alter the overall throughput. So that your latency, you can compare different latencies with the same background load. Okay. Other than that, as I said, we also count errors. And that's it. Questions? Or I can move on to the demo.
Does anyone, there was a little bit of a chat in the OpenWhisk Slack. Does anyone have any questions, or should we jump into the demo? Roderick? Demo. All right. Demo it is.
Okay, demo it is. So basically, what I'm going to show is a sample runtime under small enough conditions so that it doesn't take long. But and then I'm going to show the data, some data in the spreadsheet as I already copied. Let's see. Okay, let's do the small run so that it doesn't take long. By the way, you got there is the tool itself, that's overhead.js. You got the help switch, which details all the settings you can have. Okay, and in the documentation there is also an example that shows you various that shows you a sample invocation and the settings and the resulting settings. Okay, so okay, let's do this one. Yeah, it shouldn't be too long. And this one invokes, I already pressed enter. This one invokes 3 workers doing 100 iterations at a ratio of 4 for a rule measurement. That means we take the tool creates 4 rules and associates them with the same trigger, and then each client at the given period, that is by default that's every 200 milliseconds, fires the trigger. Okay, so what we're seeing now is the initial setup. You could see the setup command on top. Okay, so that the setup script is what takes care of creating the rules and the trigger and the action and making all the connections, making sure everything's set up. And then once the setup is completed, the workers are created. After all the workers are created, all workers are engaged. That means all workers have already passed setup, and then that means that the period of time is completed. Post-processing, that's retrieving the activation and doing the computation, starts after 60,000 milliseconds. That's 1 minute. And in 1 minute, we're actually less already because I talked quite a bit. So what we're going to see the dump. Yeah, these are the records that are generated by cross-referencing the activation data and the local timestamps, including the full profiling. Each worker essentially and the master itself, it summarizes that data using the fields I mentioned earlier during the presentation, the summing them up, computing average, etc. Everything is sent to the master, and then we have the final record. So this is the CSV header of the record. It's got 71 fields. That's a lot of information. The input, the independent variables start with input. The measurement starts with output. Okay, and then basically everything from there is exactly as the document shows. And then you get the actual record itself, the 71 fields of this particular test. These are the results. I already did import several runs to show you some examples. So this is the header imported into a spreadsheet. Is everybody seeing that, by the way?
Yeah, I can see.
Sometimes I really, okay, because sometimes in Zoom I got some flaking display. Okay. So the header is imported, and then I imported, in this case, I imported manually from several tests the records. So you can see this was an action test, and that was a blocking action test, and this is a rule test, obviously non-blocking. Okay, showing some. Let's look at some numbers. So for rules, you get the TA. TA is the time from the trigger start till the action starts. Okay, so you can see that the average value for TA is 41 milliseconds. Then you have the standard deviation, the minimum and the maximum. OEAs, that's the overhead from the beginning of the invocation at the client to the beginning of the action. That is from before the client fired the trigger till the action started executing. You can see that is 49 milliseconds. So you can see most of the time was spent in the TA part. Okay, from the firing the event to the beginning of the action was spent inside OpenWhisk from the trigger to the action. What else? So let's look at some. So you got the OER. OER, that's the total overhead for until the action ends. So for OER, again, you got the average. This is the average OER in the various cases. This is the standard deviation, again, minimum and maximum. And for throughput, I just want to show you. Let's look at the throughput. Okay, output. Lots of fields. Just a second. Okay. So this is the attempts. Just as I said, attempts is essentially the arrival rate, and the arrival rate, the throughput of the arrival rate, should match roughly the setting that was used. Okay, so what I used was I used 3 workers. Oh, sorry, no, that was another. This is from another run. Let's see. Oh, this one I used 4 workers. I used 4 workers, and yeah. Sorry, was there a question?
I was just saying yeah, you need to just wrap up fairly shortly, if that's okay.
Yeah. I didn't notice the time. Yes, thank you. Okay, so again, if you do the computation multiplying the ratio by the number of workers by the frequency, you'll see that the throughput roughly matches the value of the attempts. The attempts throughput roughly matches what you get in the computation, because as I said, that's the arrival rate. And then you can look at the service rate, that's the invocations TP, and you can see that it's pretty close. That means that OpenWhisk is still holding on. I haven't pushed it beyond its capability. One easy test you can do is if you put the settings at too high, too many concurrent workers or too high ratio, you'd see that the resulting attempt throughput would be higher. The arrival rate would be higher than the service rate, and that means that OpenWhisk is starting to lag behind. And basically, you already passed the maximum throughput it can sustain. Other than that, no, I think other than that, you can read everything else in the documentation. I think it's pretty detailed. Any questions?
I think this is great. Yeah, I mean, people always ask about performance, detailed numbers on serverless stuff. So this is great to have this kind of tool. There was a couple of questions in the chat just asking about being able to display this visually, so making it easy to import into Grafana would be good. But that's excellent. So yeah, thank you very much. And yeah, if people have questions, then drop stuff in the channel and the main list and play around. So yeah, thank you very much for that. Okay, let me quickly. We've got about 10 minutes left, so we just need to when we finish, we'll have to choose a new chat next. Oh,
James, I got one more question for me. I want to proceed with this to a PR to OpenWhisk. And I just would like to know what the reasonable location would be. The existing performance tools work in Gatling, and they already have their designated location. Should I put overhead there just as well, or should I put it elsewhere? Because they are called performance tests, because I think that some of the tests of OpenWhisk use work in Gatling, but none of them obviously uses overhead. So is it still the right location to put it there?
Yeah, so I think this should go into core. It's a very important piece of work, and I think for test, I'm hoping that the community will use it and maintain it, even if you just initial contribution. So I appreciate it. So yeah, I would say put it under test performance, and then don't replace what is there. Just create a new folder for your code, and then a README and how to use it for people to use it. As a first stage, and see if we can create something in Travis maybe to run it. But overhead is maybe not the right name. It can give a connotation, a negative connotation. So maybe we'll call it something else. We can talk in Slack and bike shed on a name, but we prefer a more positive name. But yeah, +1.
Okay.
I don't know what others think.
Okay.
okay. Well, that sounds good. Maybe any discussion, jump on Slack or the main list, and yes, that looks like a great tool. So yeah, thank you very much. Okay, so we've got about 9 minutes left. So I will, before we kind of wrap up and try and choose a chair for next time, I'll just quickly run through 3 different PRs that I thought were interesting and people might like to know about in about 3 minutes. So can people see my screen?
Yep.
Yeah, okay, that's good.
Yes.
Okay, good. So the first one, this is probably the most important one, is something Roderick proposed recently, which is actually a really important PR, but has some kind of potentially breaking changes for applications that people need to be aware of. And how OpenWhisk works today is that your API key is always available in the runtime, right? So you can use that API key with the platform library to call other actions and triggers and rules. And this is very well used under the cover. So the client library just automatically picks it up. Now, the challenge with this is that if there's any malicious code that your action ends up executing, then it can use this API key to do naughty things on the platform, like delete your actions or mine bitcoins, all this kind of stuff. So it's always a good approach to do like security by default. So it looks like we're going to change it so that you have to add an annotation to your action to inject that API key, which can then be used in the client library. So for people who don't need that capability, that is the sensible way to go. And there was some good discussion on the main list about how to implement this to be as minimally breaking as possible, but it is probably going to cause some issues. So there's a couple of things we can do. So with the client library to make this a little bit easier and things like that. But yeah, this is a big change, but it's an important change and it's well needed, but it is going to probably cause some issues for users. So it's good to be aware of. And if you have any more feedback, then kind of drop it in the main list thread or the PR. Second PR I thought was kind of cool was this one, which is was opened a while ago, but it's just merged, which is a lean OpenWhisk. So it's an instance of the platform which kind of, I think it strips out Kafka and things like that to make it much easier to kind of spin up locally and be small, as a kind of just a leaner version that people can use, which finally got merged, I think, a week or two ago. I'll go to the bottom. See lots of discussion. All right, got merged 11 days ago, which is really good. So this is nice. It makes it much easier to run locally, and again, don't need such complex components for people that don't need them. And Roderick was also suggesting that we add this into the Docker Compose spin up, right? Because again, you see a lot of problems with people with the Compose stuff where one of the many containers hasn't come up and then it dies horribly and they get very confused. So I think that's also kind of interesting, something to be aware of. And then finally, this one I just thought was kind of amazing and really interesting was it had been open a while ago, but it's finally looking like it's going to merge. And it is a container factory for Hadoop, right? So what it does is it allows your the kind of action runtime containers to run on a Hadoop cluster, kind of seamlessly use it under the covers. So people can use their existing Hadoop clusters to run OpenWhisk stuff. Which is kind of it's kind of amazing to me, the kind of things people are doing. So this is awesome. This is just really interesting. I know Roderick's been doing a lot of work, so good work, Roderick, working with the author to get the PR in shape, and it looks like it's ready to go. So yeah, I just thought this is a really interesting use case of OpenWhisk, and the pluggability of the platform enables people to do some really cool stuff. So yeah, 3 PRs I thought were interesting in about 3 minutes.
So one call for hands, Alex, what you mentioned, James, of pluggability. I think just calling I don't know how you can name it, like for help or for people to be inspired to just blog about it, blog and help with the documentation. I think this has a good SPI, extensibility, pluggability, and we just like bad in terms of bragging. We also have the Cube factory. Right now we have the Docker factory. Now we have this factory. We have the Mesos factory. So maybe someone can take up of like talking about what these factories do. Why do we have them? What are the benefits? What are the cons and pros of each one, and what would you select one versus another one?
Yeah, that's very important. You could even write a new one, like a Firecracker factory or a V8 isolate.
Somebody wants to create a template or a guide on how to create the next factory, even if it's a dummy factory, right? Something fake, just as a template.
That would be very useful. So yes, good work, everyone. I also know lots of people working hard on helping the PR, so just generally good work, everyone. Okay, so we're almost at the top of the hour. So just to say thanks everyone for coming, obviously. But again, we're going to run this. We run this every 2 weeks. The next meeting will be in 2 weeks' time, so the start of March. And we needed a chair, as always, right? And we kind of rotate this around. And all you have to do to be the chair is email people on the dev list on Monday and ask for agenda items, and then people will tell you what they want to talk about. And then remind people that the meeting is coming up, send some Slack messages, things like that, and that's about it. And then just run it as you've seen me do today. So we ask for volunteers. So I'm going to be quiet now, and you can all volunteer. Who wants to be the next chair in 2 weeks' time? Don't all rush at once. Anyone?
I think with our tenants, we're probably gonna have to volunteer more frequently on an independent basis.
Yes. So I see 2 people in the chat. I'm just going to go in order. So
I nominate Roderick.
Okay, I can second. All right, second Roderick. So confirmed. That's passed. Okay, right. Congratulations, Roderick. The next one is going to be on March 6th. So yeah, come back then, tune in. During that time, You know, the Slack channel is very active, which is nice to see. We've also got the main list, don't forget, that's Apache Way, and obviously GitHub for all the activity we're doing. So yes, thank you to everyone for coming, and Matt's been recording this, so it'll be up on YouTube relatively quickly. So okay, thank you very much for coming, everyone. Until next time, bye-bye.